All right, problem 45. In 2007, Michael Carter set a world record in shot put with a throw of 24.77 meters. What was the initial speed of the shot if he released it at a height of 2.1 meters and threw it at an angle of 38 degrees above the horizontal? Although the maximum distance for a projectile on the left, that's irrelevant. Okay, so we are looking for the initial speed. So let's draw out our free body diagram. The ball was thrown from a height, let's keep that in red, keep y in red and x in, from a height of 2.1 meters. Okay, we got a guy up here, throws the shot put from 2.1 meters, and it's thrown at an angle from the horizontal of 38 degrees and travels a distance of 24.77 meters. Okay, and we are looking for find the initial velocity. Okay, so we would have an initial velocity here that we're looking for. So first thing we can do is write down our x's and our y variables. So let's start with our x's. We have v naught x. We can write it as a formula, right? What is it? It is v naught cosine theta. Correct? And we know that our x direction doesn't have an acceleration, correct? So we know that our v average is equal to our v naught x, which is equal to v naught cosine theta. Remember, v average also equals x over t. So another formula we can write is v cosine theta. So for t would equal x over v naught cosine theta. All right, we can just plug in our theta for that. So we get, and we can plug in our x value. Remember, we have the distance, x equals 24.77 meters. So we can plug all those variables in for x and cosine. So we get 24.77 meters over v naught cosine 38. All right, and then we can also write our y direction. Delta y equals minus 2.1 meters. All right, and we don't know our final velocity in the y direction. We don't know our v naught in the y direction, but same thing we did here, we can set it to v naught sine theta, okay, which is also v naught sine 38, okay? And in the y direction, we also know our acceleration. This is negative 9.8 meters per second squared, but we don't know time in terms of y, okay? So what we're going to do is find the value for v naught by plugging in these into another formula. The formula we're going to choose for this is delta y equals v naught y plus 1/2 a y t squared. Okay, and if we just plug in all these values, we get minus 2.1 meters is equal to, we can put in, I'm forgetting something, v naught y. This is v naught y t. There you go. V naught y t. So for t, we can plug in, I'm sorry, for v naught y, we can plug in this. So we get v naught sine 38 is times t plus 1/2 minus 9.8 meters per second squared, t squared. Now we can plug this in for t here, so we get minus 2.1 meters is equal to v naught sine 38. The reason why I haven't put this is because when we get the cosine here, watch, now I'm going to put the t, this t is going to go in here. We're going to get 24.77 meters over v naught cosine 38. Minus 4.9 times 24.77 meters over v naught cosine 38 squared. So now if we just square through all of these, we end up, and we cancel out, so this with that will give us tangent 38, and what was and then 1 over cosine squared theta turns into, we can actually just run the number on that one. We don't need to do all that funny business. So if you just run all these calculations and separate them, you end up with, oh, hold on. Remember, these cancel out. That cancels out. So this will give us 19.4. Once you run sine 38, tangent 38 times 24.77, you'll get 19.4. So we get 2.1 equals 19.4 minus 4.9 times 988, that would be the 24.77 squared, over v naught squared. The cosine would go divided into that as well. There we go. That's what we're left with. So now we just solve for v naught squared. So separating that, we subtract 9.4 here, 19.4 from here, which gives us negative 21.5 is equal to multiply that through, is equal to negative 4,840 over v naught squared, cross multiply, so v naught squared is equal to minus 4,840 divided by negative 21.5, and then we square root that, so v naught is equal to 15 meters per second. Okay, again, let's see. We wrote our variables, that's plus 2 here. We got the correct answer, that's plus 2 here. We got the work here, and the arithmetic correct, that's plus 2 there, plus 2 for the free body diagram. And we have to select the correct formula. Okay, that's 5, 2, 4, 6, 8, 10.